we see that we don't have the read write. So if you had read write here, then this account has an admin rights. Hi and welcome to my channel. In the last video we used password spraying to discover valid credentials for a low privileged AD user. Today we will use that access to perform a real-world privilege escalation technique called Kerberoasting. So let's see how attackers can extract service account hashes and try to crack them offline, potentially gaining high privilege access without alerting anyone. It's perfect. Kerberoasting is a great next step after gaining low privileged credentials in an AD environment. It is practical, stealthy, and widely used in real-world attacks. Kerberoasting is a post-exploitation attack technique used in Active Directory environments to extract and crack service account credentials, specifically targeting Kerberos service tickets, TGC tickets, or TGS. So as we can see here, the attacker sending TG request and receive it. So Kerberos issues TGS tickets encrypted with a service account's password hash. A ticket granting service, TGS. Ticket is a Kerberos ticket used to access a specific service in a domain, like for example SQL server, file share, IIS. And after you've already got your initial ticket from the key distribution center or the KDC. So any authenticated user can request TGS tickets from the SPNs. But what is SPN? So SPN stands for Service Principal Name. And SPN is likely a unique name that identifies a service instance in Active Directory. It's tied to a user or computer account running that service. These tickets can be dumped and cracked offline. So the core idea, so once a user is authenticated, even as a regular user, so no rights, only very regular user, they can ask the domain controller for TGS tickets to any SPN in the domain. This is by design in Kerberos. The system assumes users need to connect to services, so it doesn't restrict requesting TGS tickets. So why this matters for attacks? The TGS ticket returned by the KDC is encrypted using the service account's password hash. A regular user can request TGS tickets for any SPN, dump them, and then brute force the hash offline. If the service account has a weak password, and this is very important here, so please don't use weak passwords. So it's only when it is the service account has a weak password, the attacker can recover it without needing elevated access. So to the SPN enumeration. So we have a tool called getuserspns.py from Impacket. What is Impacket? So Impacket is a popular open source collection of Python libraries used to work with network protocols, particularly Microsoft protocols. It is widely used in penetration testing, red teaming, and offensive security to interact with Windows environments at a lower level. So now let's run. So let's go to our cal here. Let's log in, and let's grab our first command using Impact. So here, this is the DC IP, so my domain controller IP address. This is my domain name. All this info we discovered in the last video. And we have our user here, Olivia Brown, and this is the password. So let's run that. And here we see, here we see that we have a service account, this one. So here we use Impacket's get user SPNs tool to enumerate service accounts. And the output shows usernames and SPNs. So this is the SPN and this is the name of it. So now let's add the request to the command. So we can add dash request, the same command. Let's paste this request here. To extract the TGS ticket hash. So this is the hash. This is very important here. Now we have the hash and we need to save it to a file in order to crack it. So this hash can be cracked if and only if the password is very easy. So let's copy the hash here. So copy selection. And let's create a new file called as this. So svc SQL. So as this the name dot hash. And let's paste that hash here. Paste. Control O to save and Control X to exit. And if you do ls here, we can see that we have now a file. So now we can crack that file using Hashcat. But what is Hashcat? Hashcat is one of the world's fastest and most powerful password cracking tools. It is widely used in cybersecurity, especially in penetration testing, digital forensics, and ethical hacking to recover or audit passwords from hashed values. So we have this Hashcat command. Let's grab it and paste. So, and we will use the RockQ passwords list, which we showed in a previous video. It has about 14 million passwords. And we are cracking this file or this hash. So let's click enter once there. And please be patient. As you can see here, passwords are this number. So we have so many passwords. So now, okay, now it is done. So the password here is this one, admin123. So as you can see, so the result of cracking this hash is this admin123. So now we have a password that we can try to use. So we try it using crack map and SMB. So if the user has a read-write or full control of the certain admin-only shares, like the C $, admin $, or IPC $, sometimes the sysvol or net logon for domain enumeration. So then it is a strong indicator the user is either admin or with very high rights. So let's try crack map with SMB this way. So here we are saying the IP address of the domain, the user, and the password, and show us the shares. Let's see if this. Okay, so here we see that we don't have the read write. So if you had read write here, then this account has an admin rights. So even though this SVC SQL service account doesn't have admin rights, we were able to extract a Kerberos service ticket and crack the password of a service account, all using Kerberoasting. This is exactly how attackers escalate privileges without touching any admin accounts at first. So this video is done here, but in the next video we will take this cracked password and try to move laterally. Check if the service account has local admin rights or other machines and see if we can go even further toward domain dominance. So if you are enjoying this attack chain series, make sure to subscribe, drop a comment, and follow the playlist. So we are just getting started. So thank you for watching and see you in the next video.